Good morning, children. So today we will start, we will be doing exercise 12C. Okay. So here from 12C, question number 4, here it's saying that there is a trapezium ABCD, okay, with AB parallel to DC, and they are saying that if AB is 10 centimeter, AD is equal to BC equal to 4 centimeter, okay, and angle DAB is equal to angle CBA equal to 60 degree. Then we have to calculate the length of CD and the distance between AB and CD. So here is the figure, okay, where ABCD is trapezium, okay. So let me draw over here. A, B, C, D, okay. ABCD is the trapezium, and they are saying that this angle is 60 degree, this is also 60 degree, this is 4 centimeter, this is 4 centimeter, and this is 10 centimeter. They want you to find the length of CD, okay, and they want you to find this height, okay. So what we will do is we will extend this AD, okay, and we'll extend this BC, okay. So let's say this is E, they meet at E. So in that case, now since this is trapezium ABCD, so here parallel sides are DC and AB. So if this is 60, then this will be 60. If this is 60, then this will be 60 corresponding sides. And now this triangle DCE, okay, sum of the angles is going to be 180. That means this has to be 60. So it means this is an equilateral triangle. That means this side is equal to this side is equal to this side. Clear? Let's say this is X, this is X, this is X. Now you also observe one thing, that the bigger triangle ABE is also an equilateral triangle, 60, 60, 60. That means this side AB will be equal to side AE and equal to B. That means AB is 10, that means AE is also 10, B is also 10. Here this is 4, then this has to be how much? 6. So CD will be also 6. Very easy. And now we have to find this height, okay. In order to find this height, what we will do, we will drop one perpendicular, okay. We will drop one perpendicular. So when you drop a perpendicular, what you observe, that you will observe that this smaller triangle, okay, will have two parts now, okay, and this, let's say this is 1, this is 2, then these two will be congruent, okay. That means this length will be equal to this length, but just now we have found that this whole length is 6, so this will be 3, okay, and this is 6. So you can easily find this length, okay. This length can be easily found, and then you can find this length using BPT, okay, basic proportionality theorem. Clear? So this was simply an explanation. Now I will show you what you're supposed to write in your copy, okay. So here you have to produce AD, like I said, you have to extend AD. So AD, and we have to produce BC, and these two will meet at E, okay. Now in triangle EDC, that is EDC, and triangle EAB, you can see that this angle is common, okay, and here 60, here 60, here 60, here 60. Clear? So therefore this smaller triangle and this bigger triangle are similar. Okay, so this is done. So in that case sides are going to be proportional. So ED upon EA, okay, ED upon EA corresponding sides, and EC upon EB and DC upon AB. Clear? And one more thing, that this will be 60 degree. Okay, therefore so here you can see that ED upon EA is equal to DC upon AB. So I can write ED upon EA equal to DC upon AB, but the smaller triangle, okay, EDC is an equilateral triangle. Okay, so that means EA is equal to AB. Clear? Yes. So here I am trying to say that ED is equal to EC. Okay, therefore EA is equal to AB, and your EA is ED plus DA. Okay, so ED will be equal to AB minus DA, that means 10 minus 4, 6 centimeter. ED is coming 6 centimeter. So just now, so ED is coming 6 centimeter, but we know that EDC is an equilateral, so this will be also 6 centimeter. Okay, so you will write CD is 6 centimeter. So first part is over. Okay, so for this what you will do, you will pause the video and you will copy the solution. Okay, okay. Now see the second part of this. Now we have to find the height of the distance between CD and AB. So for that I will drop one perpendicular from E on AB. Okay, so drop a perpendicular EN on AB. So here I have forgot to write N. So this is N over here. Okay, so once you have dropped a perpendicular, we will consider this bigger triangle EAN, okay, and this smaller triangle EDM. Okay, and you will see that these two triangles are similar. Okay, because here 90 degree, here 90 degree. Clear? And this is common. Clear? And this is parallel. So now we can use basic proportionality theorem also, because this ED just now you have found 6, this is 4. Okay, and you have to just find this length. Okay, because this DM will be 3 centimeter. Why? Because this triangle, let's say this is 2, this is 1, so these are congruent. Okay, so CD is total 6, so this will be 3. So you can easily find this length EM. Okay, so EM will be 6 square minus 3 square. So 36 minus 9, that is 27. So this will be 3 root 3. Okay. So we are taking these triangles EAN and EDM. Clear? So here this one is common, and EDM, that means this angle is equal to this. Why? Corresponding angles. And due to angle axiom, these two triangles are going to be similar. Okay, and once they are similar, corresponding sides are going to be proportional. Clear? And now we will substitute the values. Like ED we know it's 6, ED we know 6, therefore EA will be 10. Okay, and then EM we can find, okay, 3 root 3, and EN we don't know. Clear? So we have taken this. Now EM I have shown you. This is how we are going to find EM. Clear? And now simplify it, and you will get EN equal to 5 root 3 centimeter. Okay, so you will pause the video, okay, and you will write. So this is the second part. Okay, so I will just rub this so it will be easier for you to draw. And here actually N is missing. Okay, so you can write that. Okay, now let us see question number 8. So question number 8, in figure 12.76, this is the figure. Okay, ABCD is a trapezium and AB is parallel to DC. Is given in the figure. AB is parallel to DC, and the diagonals AC and DB intersect at E. Prove that AE into DE is equal to BE into CE. Okay, so here you can see that AE is part of this triangle ABE, and DE is part of this triangle DEC, and then BE is part of this triangle ABE, and CE is part of DEC. So here you observe that since DC and AB are parallel, so this angle will be equal to this angle. Okay, and this angle will be equal to this angle, and this one vertically opposite. Yes, so angle. So by that, let's say this is triangle 1, this is triangle 2. So these two triangles are going to be similar. Okay, and once they are similar, corresponding sides are going to be proportional. So if you are talking about DE, okay, what is the corresponding side for DE? So corresponding side for DE will be BE. So we can write DE upon BE, and corresponding side for EC will be AE. Okay, so we get AE DE is equal to BE CE. Done. So one second. Okay, so this is what we are supposed to prove. Okay, so I've just explained you what we are going to do in order to prove that. Now see the writing part. Okay, so here you will write in triangle DEC, okay, DEC and AEB. So here one correction is required. This is not C, this is B. Okay, this is B, so please correct it. So you will write in triangle DEC and triangle AEB. You can see that angle DEC, that means I'm talking about this angle, okay, is vertically opposite to this one. So therefore these two are equal. So angle DEC is equal to angle AEB, vertically opposite angles. Then angle ABE, this angle, okay, is going to equal to this. Why? Alternate interior angles. Okay, so angle AEB is equal to angle CDE, alternate interior angles. Therefore you can see that in these two triangles, two angles are equal. Therefore triangle DEC is similar to triangle AEB. You have to write B over here. Okay, done. So you can pause the video and write. And since these two triangles are similar, okay, so sides are proportional. Okay, corresponding sides are proportional, and we need only these two. Okay, so take this and here do the cross multiplication and you are done. Your proof is done. Okay, so you can pause the video and you can write it down. Now let us see question number 11. Here it says in figure 12.77, it is given that the angle BAD is equal to the angle CAE. Okay, it's given that angle BAD, that means this angle is equal to this angle, is given, and the angle B, that means this angle. Okay, let me give a star. So this angle is equal to this angle, already given to you. Now we have to prove that AB upon AD is equal to AC upon AE. So here you can see AB is part of this triangle, okay, and AC is part of this triangle. Clear? And AD is here, and A is here. Okay, so let us see. And second, what we have to prove is the angle ADB is equal to angle AEC. So we have to also prove that this angle is equal to this angle. Okay, okay, now let us see. Okay, one more thing, I think here I explained wrong. Okay, here AB, one second. Okay, I think I have explained it wrong. Okay, so here AB upon AD we have to prove, no, equal to AC upon A. So here AB and AC, okay, AB and AC is part of triangle ABC, and AD and A is part of AD, and A is part of this ADE. Okay, so right now, in order to prove this first one, we are not considering this triangle ACE. Okay, we are going to consider ABC, ABC, and ADE. Okay, so let us see the first one. So for the first one, Okay, so for the first one, we will take these two triangles A, B, D. Oh, sorry, A, B, C. Okay, we'll take A, B, C, and then we'll take A, D, E. So take triangle BAC, or you can say triangle ABC, and triangle DAF. Not DF, this is DAE. DAE. Okay, done. Now what you observe is this angle. Okay, this angle is common for both the triangles, for BSC and for DAE. Okay, this angle is common, therefore this is common, and you can see that this angle and this angle equal. Therefore let's say this is X and this is X, okay, and this is Y. So obviously this whole angle will be X plus Y, and also this angle will be X plus Y. Okay, so you can see that for triangle BAC, okay, this angle, okay, will be equal to this angle in triangle DAE. Why? Because of this common angle. Okay, so we will write angle DAC is equal to angle DSC common. Okay, we are talking about this angle is common, and these are equal. Okay, these are equal. So since this is common, therefore angle BAD, that means BAD, this angle plus this angle will be equal to this angle plus this angle. Okay, and therefore this whole angle will be equal to this whole angle. Clear? So we get angle BAC, that means this angle, okay, equal to, one second, equal to this angle. Clear? So this is done. Angle BAC is equal to angle DAE. And second thing, this angle B is equal to angle D. Okay, already given to us. And you can write angle ABC is equal to angle ADE. This is given to us. Okay, so what do we observe? That for these two triangles, we can see that two angles are equal. So in that case, those triangles are going to be similar by angle-angle axiom. And once they are similar, corresponding sides are going to be proportional. So we got this. Clear? So I have put this as star because in order to prove the second part, I will need something from you. Okay, now in order to prove that this angle, that one which is marked with this green dot, and this angle, in order to prove these two are equal, we have to join BD. Okay, we have to join BD. So see now, so join BD and also join CD. Sorry, join CE. Okay, so in actual figure this is not there. Actual figure looks like this. When you see in your textbook, you have actual figure will be like this, something like this, okay, where this is A, this is B, this is C, this is D, this is E. So in order to prove the second part, we have to join this and we have to join this, okay. So, and after that we'll show that this angle is equal to this angle. Clear? So see this now. So join BD and CE, okay, and then we will consider, now let me draw once again here, so it will look like this. Okay, so after joining BD and C, it will look like this, and we have to prove that this angle is equal to this angle, and already we have been given that this angle is equal to this angle. Clear? So now see, so we are considering triangle ABD, so ABD and then ACE, we are considering these two triangles. So here we, what do we observe, that this angle is equal to this angle, okay, this is given to us, and from the first part, okay, from the first part where we have written that sides are proportional, from first part we have this AB upon AD is equal to AC upon AE, okay. So here what we will do, we will simply interchange this, okay, AD will go up, AC will come down. So we are getting AB upon AC is equal to AD upon AE. So here if you see, AB is, one second, here you will see that AB is side of this triangle ABD, okay, and AC is side of triangle ACE, done, and then AD upon AE, so AD you see it's side of this triangle, okay, and AE is side of this triangle, and what we are getting, we are getting that they are proportional, okay, and the angle including, okay, the angle between these sides, okay, are equal. Clear? Therefore these two triangles will be similar by side angle side, okay. So these two triangles are similar by side angle side, and if they are similar, then corresponding angles are going to be equal. So you can see corresponding angle for this one is going to be this. So therefore these two angles are equal and our proof is done, okay. So we'll write, therefore angle ADB is equal to angle AEC, corresponding angles are similar of triangles, corresponding angles of similar triangles are equal, okay. Okay, now let us see question number 19, okay. So here question number 19 says that in figure 12.84, if AD is perpendicular to BC, okay, and BD equal to 4, AD equal to 6, CD equal to 9, prove that triangles ADB and CDA are similar. also prove that angle BAC is a right angle. Okay, so this is the figure. Now the same figure I have tried to make over here. Okay, because in this figure what did we observe is this AD. Okay, this AD is common for both the triangles, for ABD and for ADC. So you can think like this, okay, that these triangles are like this and they have been joined, okay, along AD to get this. Clear? So here what we have to do is, we need to show that, let's say I'm saying this is triangle 1, this is triangle 2, okay, triangle 1, triangle 2. So they are saying to prove that these two triangles are similar, and then they are saying to prove that this whole angle, okay, this whole angle is going to be 90 degree, or they are trying to say that, let's say this is X and this is dot and this is star. So if you take sum of these two, it should come 90. Okay, so firstly we are going to show that these two triangles are similar. So here what do we observe is, here 90 degree, here 90 degree, okay, and here this is 4 and this is 6, so 4 by 6, that means I am doing BD upon AD, it will be 2 by 3, and then if I do AD upon DC, then I get 6 by 9, that is 2 by 3. So here we observe that sides are proportional. Okay, the side which are including this angle 90 are proportional. Yes, so in that case, by side angle side, these two triangles are similar. Okay, and once we have shown them similar, then corresponding sides are proportional and corresponding angles are equal. So here let's say, one second, let's say, okay, one second, let me undo this. Okay, now suppose, okay, first part is done, showing that these two are similar. First part is done. Now we need to show that this whole angle is 90 degree. Okay, so suppose this is x degree. Okay, this is x degree, then this will be 90 minus x. Okay, now what we will do is, since these two triangles, let's say this is triangle 1, this is triangle 2, so since these two triangles are similar, okay, so corresponding angles are going to be equal. Now you see that first of all, here BD corresponding to BD is AD. Okay, clear? So here it's 90 and here it is 90 minus x. So for this triangle, if 90 is here, then this has to be how much? 90 minus x. So this total angle will be how much? X plus 90 minus x. Yes, so that will become 90. Clear? So that's how we are going to prove. Clear? So see this now. This is what you are supposed to write. So in triangle ADB and triangle CDA, ADB and CDA, these two triangles, 90 and here also 90. So angle ADB is equal to angle CDA, that is 90. Okay, and then BD upon AD. Okay, so here BD from the first triangle and this is second. So like you can imagine like this. So BD is of this triangle and AD of this triangle. Okay, so BD upon AD is equal to 4 by 6 equal to 2 by 3. So here I have written also BD is side of triangle first and AD is side of triangle second. Then AD upon DC. So now this AD, okay, upon DC, clear? 6 by 9, that is 2 by 3. So here AD is side of first triangle and DC is of second triangle. So we saw that these sides are proportional, okay. So therefore these two triangles are similar by side angle, side axiom, okay. And sides are proportional and therefore angles, corresponding angles are equal, okay. So here corresponding angles are going to be like this. So corresponding to this, okay, will be this, and corresponding to this will be this, okay. So let's say this one is x degree, this is x degree, so this has to be 90 minus x, okay. So if this is 90 minus x, then this will be also 90 minus x. Now if you take sum of these two, x and 90 minus x, obviously you will get 90 degree, okay. So corresponding sides angles are equal, so angle ABD is equal to angle CAD, and angle BAD is equal to angle ACD, angle BDA is equal to angle CDA. Now I am taking angle ABD as x, okay, then angle BAD will be 90 minus x, clear? Now we have to prove that angle BAC is 90. I have to prove that BAC is 90. That means I have to take sum of angle BAD, okay, that means I have to take sum of this angle and sum of this angle, okay. So I have written angle BAC is equal to angle BAD plus angle CAD. So angle BAD is how much? 90 minus x, and angle CAD is how much? X. So we are getting 90, okay. So proof is done, okay. So this is all for today's class. So you can just pause the video in between and you can copy this.